In this unit, we're going to explore more about perpendicular bisector. Specifically, we're looking at a perpendicular bisector theorem here, which states if a point lies on the perpendicular bisector of a segment. So again, here, a perpendicular bisector of a segment, what that is this line, blue line right here, CD, this line, because this is perpendicular to one side, and it's also, D is the midpoint. It's bisecting one of the segments. So any points, if I use a different color, let me use my favorite purple, any points on that line, including the vertex C, it's equidistant from the endpoint, meaning CA and CB are all congruent. So that's our conclusion here, that CA and or AC rather, segment AC and CB are congruent. Okay, so again, as long as that point is on that perpendicular bisector, it's equidistant to both vertex. Probably, the easy example you can relate to is probably a cross on top of a church. If you think about, a cross like that, any points on that cross is equidistant to the two endpoints. And another example is actually I just drew a kite when you connect the dots with the red marks I just drew there. That's an ugly picture, isn't it? But you got the point that it's CA and CB are congruent there. Now, again, pay attention to the vocabulary here. Remember, converse of a theorem is simply we switch the hypotenuse with a conclusion. So if we say if P then Q, the converse of that is if Q then P. So how is it applied here to perpendicular theorem? And it says that if I have a point that's equidistant from the endpoints of a segment, then it's on the perpendicular bisector of the segment. In other words, if I know that C is equidistant to A and B, if AC and AB are congruent, then I can be sure that CD is a perpendicular bisector, which means CD is perpendicular to AB, as well as cutting that AB in two equal halves of AD and DB. Okay, so how is this used? Let me move this up a little in some examples. So here we're asked to find the value of x, and what's given is two conditions. We're given that it's perpendicular and it cuts that segment in half. So I've got a perpendicular bisector here. Therefore, I can draw the conclusion that these two sides are congruent because any points on that perpendicular bisector is equidistant, meaning the same distance to the endpoints, or to the other two vertex. So that's my setup. And if you do your math right, it should come out to be 12. Okay, and see if you can finish 2 on your own and 3 on your own. And remember to pause the video. I will do number 4 with you. So number 4, I know that D, these two sides are congruent. So DG must be the actually I'm looking at this, let's see. Yeah, so this I have to use the converse, right? Notice the difference here. In question 3 and question 1, the right triangle is given, whereas here the right triangle is not given. Whereas in this example here, let me try a different color, and in example 4, the why is this not working? Here we go. Sorry about that. So the two segments, two sides are congruent are given, whereas here they're not given. So you can be given a problem that given one relationship and not the other, but you're asked to draw the conclusion by using either the theorem or its converse. So in this example here, because we're told that, let me erase, no, I can't erase this. So let me just go ahead and do this. Because we're told that these two segments are congruent, and by the converse of the perpendicular bisector theorem, we know if these two lines are congruent, DG must be a perpendicular bisector. If DG is perpendicular bisector, I know that 2x plus 11 must equal 14 minus 37, right? So this, by the way, is by the converse of perpendicular bisector. So that's 14x. So if you do your algebra, that's 12x equals whatever, and then the x would come out to be 4, I think. Now, then we're not asked to find out x, we're asked to find out EG. EG would be 2 times 4 plus 11. That should give me 19, right? Okay. So let's do another one. Let's do number 6. Number 6, I'm asked to find JK. And here, I'm given that these two are congruent, and I've got the right triangle here, so I know this is my perpendicular bisector because of this right triangle here. It's perpendicular, right? So then I know that JK and KL must be congruent. So that's your setup. That's 3x, that's 60, so that's x finally equals to 20. And then if you plug in to your JK comes out to be 94, is it 94? Yeah, that's JK. So JK is here. Okay, now let's go back to do number 5. Number 5, I know that C is equidistant to AB, so by converse of perpendicular bisector, I know my CD must be perpendicular bisector. So because of that, I can set this up to be this, and my x should come out to be 14, and I'm asked to find AB, which you just have to substitute it in there. So it's so you can do 5 times 14 minus 11, and you can multiply that by 2, or you can plug it into 3x plus 17 and add them together. So you should have about 118 is the length of, the length of AB. Yep. Okay. So this is not hard, but it does require you to be crystal clear about the definition of perpendicular bisector. All right, guys, I'll see you later.